Hey mathematicians, let's do your homework. All right, so we are going to be doing order of operations, and I'm going to write GEMDAS next to my problem so that I can remember the order that I'm doing things in. I'm going to start with number 2. Do you have grouping symbols? Yes. So we are going to look inside our grouping symbols at that 9 plus 33 minus 6. If there are 2 operations, we follow order of operations for them. So no grouping symbols inside our grouping symbols, no exponents inside it, no multiplying and dividing inside it, but there is adding and there is subtracting, and they're on the same level. So then we decide what to do because which one's first? 9 plus 33 is first. So 9 plus 33 is 42. And then I'm going to rewrite the minus 6 and keep it in parentheses, and the divide by 6, and the minus 3 to the power of 2. I am not done with my grouping symbols, so I'm going to keep going back until it's one number. So next up is 42 minus 6. Honestly, what I think about is I know that 6 times 7 makes 42, so if I'm taking away one group, that's like 6 times 6, that must be 36. And that's one number now, so I can drop my parentheses. And I'm done with my grouping symbols. Next up is exponents. 36 divided by 6 minus 3 to the power of 2 is really 3 times 3. That's not 3 times 2. It's not 6. It's 9. I've cleared my exponent level. I'm moving on to the multiplying and dividing level. I am not going to touch that subtraction until I've cleared my multiplying and dividing level. So 36 divided by 6 is 6. And then I keep my minus 9. This is an issue a lot of us were having in class. 6 minus 9 is not 3. It is not a positive number because I start with a smaller number and I'm taking away something bigger than 6. So you can do 9 minus 3 and say, okay, the absolute value of my answer is 3. I'm sorry, 9 minus 6, the absolute value is 3. But it's not actually 3. It's really a negative 3. And that's my answer. So you're going to walk through each and every step for each and every problem. If you're not showing me nice organized work, you will make a mistake. An easier one, because I'm not going to do all the hard ones for you. Writing it out. Are there grouping symbols? No. Are there exponents? No. Is there multiplication or division? Yes. Start with whatever you see first. 24 divided by 4 is 6, plus 14 times 2. I don't care that you read the plus first. It's not on the same level as the times. So we're going to that times next. 14 times 2 is 28. Plus 6. Now we've cleared the multiplication and division level because there's no more of it left. We can do our final answer, which is 34. So that's the process you're going to take for each of them. If there's more than one operation inside the parentheses, like looking at that number 6, you follow the order of operations. Exponents, then multiplication, then addition. Then you move outside your parentheses to deal with your other multiplication, and last your addition. Let's go on the back. On Saturday, Jamie was raking leaves from his yard and filled 2 2/5 bags of leaves. On Sunday, he raked 4 1/3 more bags of leaves. More. Is that an adding, subtracting, multiplying, or dividing? It's not for every, it's not less than, a more is a plus. 2 2/5, and then you did some more. Reminder that when you are adding into, no, not integers, well, yes, but if it's a fraction integer, they need to have common denominators. 5s will not simplify to 3s. 3s will not multiply to equal 5. So when you need a common denominator and you can't find one that can match, you're going to change them both. And really, I just go for what's 5 times 3. So I'm going to change my 2 2/5. I'm going to make it 15ths. I don't need to change my 2. I can just change my fraction. 5 times what number makes 15? 3. 2 times 3 makes 6. So this is now 2 6/15 plus 4, and we need to change 1/3 to also be 15ths. 3 times 5 gives you 15. 1 times 5 gives you 5. So now you can add your whole numbers. 2 plus 4 is 6. And you can add your fractions, which will stay with a denominator of 15. 6 plus 5 is 11. That's how many bags of leaves Jamie raked throughout the whole weekend. Dory was making a cake recipe that called for 2½ cups of flour. She wanted to make a cake that was 3 times as big. Oh, it even tells you what we're doing. 2½ times 3. Remember that you need to make your mixed number into an improper fraction, and you need to make your 3 into a fraction before you can multiply. Joe poured himself a 16 fluid ounce glass of chocolate milk. When he took the first sip, he drank 3 3/8 fluid ounces. How many fluid ounces were left after he took his first sip? Well, if you're drinking, you're not getting more chocolate milk. You're getting less. So this is a subtraction problem. 16 minus 3 3/8. To do mixed number subtraction, I'm actually going to change this. Like when you regroup and you borrow 1, I'm going to borrow 1 from 16 and make that 15 wholes. And I'm going to write my extra 1 as a fraction out of 8ths, but it still has to make 1 whole. So it's going to be a fancy 1 fraction. 15 8/8 minus 3 3/8. Now I can subtract my whole numbers. 15 minus 3 is 12. And I can subtract my fractions. That'll keep a denominator of 8. 8 minus 3, 8, 7, 6, 5. You end up with 12 5/8 fluid ounces. Number 10, is that our last one? Yes, it is. Joanna's working on a new project in her home. She's going to rip out all the carpet in her bedroom and change it to hardwood floors. I need this in my life because my bedroom has carpet in it, and that is the only place my cats like to vomit because, you know, it's the hardest place to clean. They don't vomit on the easy clean floors. They just vomit on the carpet. Fun fact about Mouse and Piglet. All right, she has a long piece of wood to start off her project. The piece measures 12 feet in total. So she's got this very long piece. She's probably going to end up cutting it up. She wants to cut the piece of wood into smaller pieces, each one measuring 1 2/3. So we're going to cut 1 2/3. 1 2/3. I bet they're going to ask us how many 1 2/3. How many whole pieces, each measuring 1 2/3, will she be able to get? So this is a division problem when you cut it into the same size pieces. We start with what we have, which is 12. We divide it into the size piece we're trying to make, 1 2/3. And before we do keep change flip, we make them both improper fractions. 12 becomes 12 over 1, divided by 3 times 1 is 3. Plus 2 is 5. 5/3. Keep the first fraction. Change it to multiplication. Flip the second fraction to find the reciprocal. That gives me 36/5, which I'm going to change back into a mixed number. 36 divided by 5. 5 goes into 3 0 times. 5 goes into 36. 7 times gives me 35. And 1/5 remaining. But the question was how many whole pieces. So my answer is you can make 7 whole pieces, and then that extra bit you're just going to save for another project because that's not going to get you the piece you need. So 7 whole pieces. Did I spell pieces right? I did. That's such a hard one for me to spell. And we're done with our homework until after Thanksgiving. Yay!